Chapter 17, number 26. So what's going on here? P, the probability that a frog has the trait is 1 out of 8, or 0.125. N is a dozen frogs, okay? And now we're told the frequency doesn't change. It hasn't changed. So we have to run through the Bernoulli preconditions here. It's yes or no. The frogs have the trait or they don't. That's number one. Number two, does the probability stay the same? Well, we're told it doesn't change, so the probability is constant. We also know that that n, the size of the sample of 12, is certainly less than 10% of the population of the frogs. And three, we have no reason not to assume that these frogs are not independent of each other. So then they ask 4 questions. What's the probability he finds the trait in none of the frogs, at least 2, 3 or 4, or no more than 4? So let's look at the setup for this. So P is 1/8 or 0.125, N is 12, Q is 0.875. And since we're talking about a set number of events and a set probability, and we're looking for, the various questions are about how many the times the trait shows up, and we're going to use the binomial probability. So A, what's the probability that the number of frogs with the trait is 0? Well, that would simply be the probability that none of them have the trait. Now, the probability that none of them have the trait is 0.875, which is approximately equal to 0.2014. So, all right, so that's the answer to that. What's the probability that none of them have the trait? 0.2014. B, what's the probability there is at least 2 frogs with the trait? So what's the probability that the trait is greater than or equal to 2? So that means, what's the probability that the trait equals 2 or 3 or 4, etc., all the way through 12? Which means that the probabilities for 2, 3, 4, etc., all the way up to 12 should be added together. Now, the easiest way to do this is to take 1, the sum of all probabilities, from 0 to 12, and subtract from 1 the probabilities of 0 and 1. So to do that, we can do 1 minus binom CDF, 12, 0.125, 1. And so let's just review that. How we do that? So second and then vars, and we arrow up to binom CDF. In this calculator it's B, but it can vary. 12, 0.12. Here, let's do the whole thing. 1 minus second vars binom CDF 12, 0.125, 1. And I have a typo here. I should have checked before I hit return. 0.125. So the probability is around 0.45. What's the probability that you get exactly, out of 12, there are exactly 3 frogs or 4 frogs with the trait? So to calculate this, we'll use binom PDF and do the exact calculation for 3 and the exact calculation for 4 and add them together. So it would be second, and then vars comma 3. So I'd enter. Now I'm going to store this because I can't add to it. So I'll store this in A. And then I'll just run the thing I just did. And I'll change the 3 to the 4. And then I will add A to it where I stored the previous answer. So it's about 0.707 probability. And finally, what's the probability that the frogs with the trait that there are no more than 4 frogs that have the trait out of 12? So that means you want to know the probability of 4 or 3 or 2 or 1 or 0. So to get that, binom CDF 12, comma 0.125, comma 4. And that probability is quite high. That's it for 26.